In this video, I am going to be talking about three C++ template class topics: non-type template parameters, default values for parameters, and multiple parameters. I am going to be using this existing template class to explain those topics. The topics of discussion are non-type parameters, these three topics. First, let me explain this code. This is a class template to manage array, which also keeps track of number of elements in the array. The capacity of array is 100, and also it keeps a record of capacity. Default constructor initializes number of elements to 0 and capacity to 100. Array, this is a custom constructor which is to receive an array and size, and the logic actually copies the content of the array into the array that is to be managed by the class. It also has overloaded bracket operator or subscripting operator to allow the object of this class to access the elements, and also it has a size member function to return the size of the array. That means number of elements in the array. In the main function, I have an integer array of heights and double array of marks. And this is the application of integer array. Let me remove this part of the code so that I'll have shorter code to explain better. Now, class template instantiation and object creation, and this actually displays the content of the array. And again, class template instantiation and object creation, and it displays the content of the array. If you want to know about this detail about these things, then you watch another video which is going to be in the description. I'm going to be focusing on non-type parameters. First, let me explain type parameters. Okay. The parameter that is to be replaced by one of the existing types, int, double, is a type parameter. In this case, t is type parameter, right? It is used as a type of the array elements, and it is used in different places. For example, as type of the incoming array to be copied and the type of the element to be returned. Now, non-type parameters are the parameters which is of existing type. For example, in this case, if you use this template to create an object, the size of this object is going to be always 100. Not size but capacity. This object is going to be able to hold maximum 100 elements. If you want a more flexible array which may be able to hold not 100, not only 100 but 200, 400, depending on your requirement. In other words, you want to be able to create an object or array with the capacity of your choice. Right? In that case, the use of non-type parameters can be helpful. The way you want to use non-type parameter is you can put in this angle bracket, comma separated list with the previous parameter, and I'm going to be using integer type non-type parameter. So int and the name of the parameter. This is a non-type parameter. I may be able to use this n to specify the size of the array, so that based on what value this n gets, you'll have array of corresponding size. Could be 500 elements, it could be 1000, it could be 2000, 10,000, depending on your requirement. Now if you have n, then the capacity is going to be n, so I want to be able to copy this n to capacity as well. I think that is all changes I wanted to make here. So again, this is type parameter, this is non-type parameter. Going down to the code, if you want to instantiate that class, then you need to specify both type and non-type parameter, right? If I want to instantiate the class for integer type and non-type parameter 100, that means I want the size of the array to be maximum 100 elements, right? Or you want to instantiate the template for double type, and you want that array to be able to hold 1024 elements, right? So this will create a bigger size array, this will create a smaller size array, but this gives you flexibility to specify the size of the array at the time of instantiation, right? Let me compile this. This code should this object is created by copying this array data into it. This array should actually display this data, not this data, but the data that was copied into, same data copied into the array, but that data is stored in different memory space allocated for IAR, different than this height array. Similarly, same thing happens here. DARR should display this data, all this data, but the data that is stored in the memory space allocated for this object. Let's see the output. So this is the output, right? This was the size. Size doesn't appear here, but actually size was set. If you actually want to look at see the size, what size it was set to, then we can have another function to return the capacity of the array. So if I have this function, then I should be able to display what is actual capacity of this array. I want to display capacity over here. Right. Similarly, I would like to display the capacity of this array in this place. Right, let me compile and see the capacity of corresponding array. In this case, it should be 100. In this case, it should be 1024. Now you can see the capacity displayed. In the first case, it is 100, and second is 1024. So definitely, you are now able to specify the size of the array at the time of instantiation. The next topic to be discussed is default values for parameters. If you want this array to be class to be instantiated by using default value instead of specifying here. For example, if I want to instantiate the template class for int type, but I want it to use some default value, right? Some default value that is specified. I only want to specify int. Or in case where the instantiation is attempted by using this kind of statement, then if there is a default value set, then that default value will be used. Otherwise, the value, the size, the value for the non-type parameter must be specified, right? The way you set or specify default value is equate this non-type parameter to, let's say, by default I want an array to be of size 512, right? If this the data for this non-type parameter is actually specified in the instruction or statement for instantiation, then that data will be used. Otherwise, this default value will be used in this case, right? So now it is not showing complaining. That means the default value is being used. And you can also specify default value for type parameters. For example, if you want by default it to be int, then you can equate it to int. With that, you will not be required to specify any of the type that you want to replace the type parameter and non-type parameter with. You can just create an object free like this, right? In this case, both type and non-type parameters are used, set to default values. In this case, type parameter is set to int, non-type set to default value. So this is the way you can specify default values. And one thing to note in this case, or be careful about in this case, is you cannot, if you set default value for one type, then you have to set default value for all the types that come after that. For example, if you set default value for t, then you cannot leave default value for n like this. So this is going to be an error, right? If I try to compile, it should complain. So now it is actually missing the template parameter, default parameter, so it's complaining. Even if this it is not showing like, but when you compile, you'll get into error. But if you have default value on the rightmost parameter, then you don't need to have default value on the parameter that precedes that rightmost parameter, right? So it has to go that way. If any of the parameter, it could be you may have more than 2 parameters here. It could be 5, 10 parameters. If, for example, if 5th parameter has default value, then you must have a default value specified for 6th, 7th, 8th, 9th, 10th, all those values. Okay. Now, with after this, I'm going to be talking about this multiple type parameters. In the situation where you want to store different data items, or you want this class to manage different data items of different types. Like, for example, I want a class to be able to manage both height and marks together in double type, or int type data and character type data, array, or int type array, or the array of some other different type. In that case, you want to have another array. Let me call it 2. The size I'm going to specify like this. I'm going to be using, now I'm using the same size, but the type is going to be different, because these 2 elements are not necessarily holding the data of same type. If you want to use different type, then you need to have another type parameter here. Let me remove this default values for to simplify the problem, simplify the explanation, I'm gonna remove these things here as well. So you can have multiple type parameters, you can have multiple non-type parameters, or you can have multiple type parameters and one non-type parameters, right? So first array type parameter is t and size n. In the for the case of second array type parameter u, size is m. Now you need to make some changes. You may have to store multiple capacities. This may complicate the things, so I'm going to remove this second non-type parameter and use the same, assume that both arrays are of the same capacity, so that I will not have to store extra stuff. And also my assumption is that these two elements are going to have same number of elements. These two arrays are going to store the same number of elements, so I need only one size parameter to keep track of, right, to simplify the problem. Now I don't need to make any changes in this function, but I need to receive two arrays, one of type t and another of type u. Right, and size is going to be the same, that is my assumption. And here I would be adding elements, copying ARR to validation also requires some changes. I also want to make sure that the second array is also valid, and I want to copy the second array element to the second attribute array, right? Now overloading this operator to return both elements of both arrays is going to be a little bit complicated, so I'm going to be using a function. I'm going to be using this function to return which receives index and return the element of second array. And return again, the return type is going to be similar to the previous function, your type and reference. So because I'm not able to use this unless I do some complicated stuffs here, so I decided to use the function in this case. Now size return is going to be same, capacity is going to be same. Now with this change, I should be able to use this template class with multiple or two type parameters. So to use that, you need to specify the types. For example, in this case, I want to store int and double type, and I pass marks, right, and I can display both the first item data and first array data and second array data. I dot this function. It's going to be dot I. So let me remove capacity display for the moment. It will display all the data items from two arrays in a single line. The items corresponding to one element are displayed in one line, but multiple items are actually displayed in different lines. Let me see the output here. One small issue here is that since you are returning by reference, you are allowing this function to make changes to the attribute data, so you cannot make it query. So I need to remove this constant. Now let me try to run it again. So it is running okay. You can see the output, right? So both data are managed, 162, 16, 62.1, and so on and so forth, right? Height and marks are actually managed together. Quick recap: we discussed non-type template parameters, default values for parameters, and multiple parameters.